Let's jump right into this explainer. Today, we're unpacking a genuinely mind-bending document by philosopher Nick Bostrom. We're looking at the idea that human evolution, well, it might just be getting started. If you've ever found yourself wondering what actually comes next for humanity after our current stage of development, you are in the right place. We're going to break down this entire concept using a really clear visual roadmap.
We've got a highly logical evolutionary roadmap to follow today. We'll kick things off by defining transhumanism, map out the transhuman transition, look at near-term stepping stones in biotech, explore the nanotech assembler breakthrough, the rise of superintelligence, and finally, we'll arrive at our ultimate posthuman destination.
Okay, Section 1, Defining Transhumanism, our philosophical baseline. Before we start projecting into the far future, we really need to set the stage and ask, what exactly are we talking about here? So, transhumanism. It's essentially this growing intellectual and cultural movement, and it firmly affirms both the possibility and the desirability of fundamentally improving the human condition using applied reason and technology. The main goal? To eventually eliminate aging and massively enhance our intellectual, physical, and even psychological capacities. Basically, it views our current human form not as the finish line, but kind of like a comparatively early phase of our development.
Now, what's really fascinating here is how transhumanism builds directly on traditional humanism. Humanism, the belief that humans matter, that we can improve the world through rational thinking, education, and democracy. Transhumanists, they agree with all of that entirely. But instead of just using those tools to improve the outside world, they're saying, hey, let's use technology to fundamentally improve the human organism itself. And look, this isn't just fringe science fiction anymore. These ideas are rapidly entering the mainstream. You've got serious, growing networks of scientists, philosophers, and social thinkers gathering under big umbrella organizations like the World Transhumanist Association to rigorously study both the incredible promises and, frankly, the potential dangers of these technologies.
But looking at the world today, that brings up a pretty excellent question. With all our modern medicine, instant global communication, smartphones literally glued to our hands, aren't we kind of transhuman already?
That brings us to Section 2, the transhuman transition, an intermediary form. Let's clear up some of the pop culture confusion around this and set some firm boundaries.
In contemporary terms, a transhuman simply refers to an intermediary form, a stepping stone between the human and the posthuman. Now, back in the day, the futurist FM 2030 coined this as a transitional human. He pointed to things like prosthetics, plastic surgery, or even a globetrotting lifestyle as signs we were getting there. But let's be real, simply changing how we think about ourselves or using a sleek new cell phone doesn't actually alter our fundamental biological limits. The changes we're talking about have to be far more profound than just a mindset shift.
Which leads us to Section 3, near-term stepping stones, biotechnology, the physical shift. Because to truly alter those hardwired human limits, we have to look at our first major technological leap.
Reporting strictly on the science here, we really need to differentiate between two types of genetic therapies. First, you have somatic therapy. This uses a vector, like a virus, to insert new genetic material into a patient's cells. But the crucial thing to remember is it only affects that specific patient. It's not passed on. Germline therapy, on the other hand, is performed on sperm, egg cells, or a really early zygote. This is a game changer because those changes are inheritable by the next generation. We're talking about the incredible potential to intercept and prevent single gene disorders like cystic fibrosis or Huntington's before someone is even born.
And this perfectly illustrates another massive distinction in medical research, specifically regarding cloning. Therapeutic cloning aims to extract stem cells so we can grow specialized replacement tissues, say for a failing heart or to treat Parkinson's. Because they're a perfect genetic match to the patient, they completely evade the body's immune rejection. Reproductive cloning, in stark contrast, would result in the actual birth of a child genetically identical to the parent, literally a younger identical twin. So as you can see, these are two wildly different applications of biological mastery.
Now, biotechnology is undeniably powerful, but at the end of the day, it's still constrained by messy biological processes. As we look past these near-term stepping stones, the big question is, how do we achieve total, absolute mastery over matter itself? Welcome to Section 4, the assembler breakthrough, nanotech. This ushers in the nanotechnology era, a concept that promises to flip our relationship with the physical world totally upside down.
Molecular nanotechnology is this anticipated manufacturing tech that essentially turns manufacturing into a software problem. Imagine being able to control the structure of matter on an atomic scale. We're talking about building complex, three-dimensional objects, literally atom by atom, using microscopic, non-biological machinery.
I absolutely love this quote from K. Eric Drexler, the pioneer of these concepts. It poetically highlights a pretty mind-blowing fact about our universe. Dirt and supercomputers, they use the exact same basic building blocks. Coal and diamonds are both just carbon. It is literally just the arrangement of those atoms that distinguishes the cheap from the cherished, or the diseased from the healthy. Nanotech, theoretically, gives us the power to just rearrange them.
So, how would this actually play out step by step? Well, think about how biological ribosomes assemble proteins in our cells, amino acid by amino acid. Nanotech assemblers would be like tiny robotic construction workers. They'd grab molecules, position them perfectly, and even build copies of themselves to work in massive swarms. Working together, they could construct incredibly clean, flawless macro objects super fast. Basically, you could theoretically build almost anything as long as you have the raw atoms, like carbon from a pile of dirt, and the right software instructions.
Okay, so if we can eventually rearrange atoms perfectly to cure any disease or build any physical structure, the next logical question for this explainer is, what on earth does this mean for human cognition?
That takes us to Section 5. The rise of superintelligence, expanding the mind. We are officially entering the realm of advanced artificial and augmented intelligence. A superintelligence is an intellect that radically, and I mean radically, outperforms the best human brains in practically every single field. And we aren't just talking about a calculator that does math faster. We're talking about scientific creativity, general wisdom, even social skills. Many transhumanist thinkers firmly expect this level of intellect to be created within the first half of this century, totally driven by exponential advances in both hardware and software. To really wrap our heads around this, we need to separate weak from strong superintelligence. Let's use an analogy from the source text. If you were to somehow upload a human mind into a computer and run it 1,000 times faster, that gives you weak superintelligence. You're thinking 1,000 times faster, sure, but you are still fundamentally thinking human thoughts. Strong superintelligence, though, that implies entirely new layers of cognitive architecture. Think of it this way. Speeding up a dog's brain won't ever give you a human intellect capable of understanding quantum physics. Similarly, a strong superintelligence would have types of smartness that are currently completely inaccessible to our biological brains.
So, let's put the pieces of the puzzle together. With total mastery over genetics to eliminate aging, nanotechnology to control matter, and superintelligence to massively expand the mind, where does this evolutionary roadmap ultimately lead us?
Here we are, Section 6, the posthuman destination. We have finally reached the ultimate endpoint of our theoretical journey today.
A posthuman, whether that ends up being a completely synthetic AI, a human mind uploaded to a vast computer network, or just a radically modified biological human, would possess traits so far advanced they're no longer unambiguously human by our current standards. We're talking about beings completely impervious to aging and disease. Beings with total control over their own mental states, imagine never feeling petty irritation again, that experience increased capacities for pleasure and serenity, and entirely novel states of consciousness that our 3-pound lumps of biological neural tissue simply cannot fathom right now. As the source material points out, simply living an indefinitely long, healthy, and active life might naturally push us past human boundaries anyway, just as we accumulate centuries of memories and skills. It really forces us to look inward today. If the tools are rapidly approaching to reshape our very nature, what kind of future do you actually want to build? And maybe more importantly, if you had the choice, what kind of posthuman would you choose to become? Think about that for a bit, and I'll see you in the next explainer.